Okay, so we are doing polynomial division today, but our polynomial division has a purpose because polynomial division is going to help us find which things are factors. Okay, so if you think about the word factor, if I ask the question, is 4 a factor of 36? Just give me some kind of indicator. Do you know how to answer that question if I ask that question? I'm looking for a thumbs up, thumbs down. Do you know how to answer that question if I asked? Okay. So is 4 a factor of 36? The answer to that is yes. Why? Why? Yeah. And there's no exactly 36, right? Yeah. It's not like one of the ones that we did in our opener today and there was a remainder. So in order to be a factor of something, I hope you would agree, let's write it in the division way. That number should go into the number under the division symbol. So this goes in 9 times with a remainder of 0. So that's my remainder right there. Okay, so I guess I want you to keep that in mind today because the key thing is in order for polynomials to be factors of other polynomials, the same thing has to be true. If I ask the question, is something a factor, then it would have a remainder of 0 when I divided it. Okay, let me show you one. And you guys are really quiet. You're going to need to ask some questions on this. You've never seen this before. So my example, we're going to check by polynomial division, is x plus 4 a factor of x squared plus 6x plus 8 is my question. And some of you already know the answer to this question without doing this, but I'm going to show you why. Who thinks they know the answer to this without? Really? Okay. We did factoring in the past. Remember those binomials? So my question is it possible to factor in that way? All right, so here's what we're going to do. Underneath the division bar this time, we're going to put x squared plus 6x plus 8. And we're going to divide it by x plus 4. And we're going to do our division, which I hope will make sense to you based on the fact that you remember long division. And we're going to see what the remainder is. Okay. Now the difference is before they were just numbers and here we have x's. So I'm going to just have you take a look at the first things. And the first things are this x and this x squared. Okay, my question to you is how could I get x to go into x squared? Or another way of asking that is what's x squared divided by x? Tell somebody around you. What's x squared divided by x? I'm hearing x squared divided by x is x. So the very first thing you're going to do is you're going to just kind of cover up these things and you're going to divide those first terms and you're going to figure out what the quotient is. That's the word for when you divide things. So what's x squared divided by x? It's x. Does that make sense? What you're going to do next is you're going to take that x and you're going to multiply by both things and you're going to put it underneath. So here we go. What's x times x? X squared. So I'm going to put that right underneath my x squared. What's x times 4? 4x. Now, what would you normally do next in long division? If you were doing the one up the top, what would you normally do with these? You'd normally subtract them. Guess what we're going to do? We're going to subtract. Would you put the parentheses around them to remind us that we're going to subtract each thing? All right. What's x squared minus x? 0. Good. What's 6x minus 4x? 2x. Positive, right? Okay. All right. Think back to long division. Think back to long division. What would you do next normally? Drop down the next thing. So guess what we do next? We just drop down the next thing. We're going to drop down that 8. Okay, I'm hoping you can follow this based on kind of the long division. Okay, let's do it one more time. We need to have x go into 2x. I cover up these things. How many times does x go into 2x? Or another way of asking that is, what's 2x divided by x? 2. So this is a 2, positive 2? Okay, so I'm going to write plus 2. And now we multiply. What's 2 times x? 2x. What's 2 times 4? 8. We subtract it. And we get a remainder of 0. Remember my question above. My question above was, is x plus 4 a factor of x squared plus 6x plus 8? I got a remainder of 0. So what is the answer to that? It is a yes. It is a yes. Okay, now let's go further. That means if they're factors, I can write them in 2 parentheses. So the factors of x plus 4, or sorry, x squared plus 6x plus 8 are x plus 4 and x plus 2. Okay, does that make sense? That looks familiar? Kind of just bringing everything back to something you already know. Let's see how good our memory is. Can anybody tell me then what are the x-intercepts of the graph of that? If you think you know, would you talk to the person next to you or in front or behind? If I told you this, what are the x-intercepts on that graph? Aiden, what did you guys say? -4 and -2. So just kind of remember factors relate to x-intercepts, and that's still true. The x-intercepts would be x equals -4 and x equals -2. Okay. Does this, I know it's a stretch, but does this make sense to you? Would you like to see one more before you try it? Okay, we'll do one more together. So, is x plus 2, well, I should do one maybe, yeah. Is x plus 2 a factor of x squared plus 10x plus 25? Okay. So we're going to put in underneath x squared plus 10x plus 25. then the outside, x plus 2. We're going to just look at those. And we're going to ask ourselves, how many times does x go into x squared? Or, what's x squared divided by x? Just x. All right, would you take that x and you would multiply by this and put it below? All right, next we subtract. Don't forget to subtract the whole thing. X squared minus x squared, that one should always cancel because we specifically picked it to go in an equal number of times. 10x minus 2x is 8x. We drop down the next thing, the plus 25. Now we're going to do 8x divided by x. What's 8x divided by x? 8. Write down an 8. All right, so we have 8x. 8 times 2 is 16. If we subtract, what do we get there? 25 minus 16 is 9, right? Okay, so what this means is we have a remainder of 9 left over. So then the question, is x plus 2 a factor of x squared plus 10x plus 25? The answer would be no, because I got a remainder that's not 0. So if I don't know the factors, then I can't say anything about the x-intercepts or things like that. Okay,